Hello everyone. Ooh, wow, 17 of you. That's great. That's great to see. 18. Nice. How have you been doing? How have you started maths, the maths assignment for assignment 3, maths assignment 3? It's really fun. Okay. How many questions have you managed to do? There was a webinar last week, yes. Did they not publish it? I believe I published it. The 15th of, no, that's 14th of November. Yes, I did a webinar and it's published. So yeah. Halfway problem 8. Okay, very good. Can you just type a number in the chat? How many questions you managed to do so far? If it's 0, it's fine. Just put a number. Assignment 3 is published. Okay. Now, it is not on the website. Yes, it's not on the website, but it is on Canvas. Yes. Is there anyone here who does not have access to Canvas? It might be because you are in the follow along group. But if you're following, you will receive a link soon. It's just we're sorting out. But if you are in the main course, maths 1003. Where's that? 1003. That's not. Uh-huh. I see. Just give me one more second. Mhm. I'm not sure how this happened. Okay. So it is available. Something went wrong. The link was broken, and sorry about that. And I'll post the link in the chat. Let me know if you can access it. Where can I find it? Because I'm not in Canvas. I'm to follow along. If you're on the follow along, well, please download it now, and we will send it to you in a few days as well. Where you find it in Canvas, it's on on the assignment. Okay, it works. Okay, excellent. Assignment will be the physics assignment will be out later this week. Okay, so the deadline is on the 17th of December. So you have plenty of time. You got 4 weeks to do it. Right, and yeah, so we're doing coordinate geometry. So coordinate geometry is geometry on the coordinate plane. We are only going to do Cartesian coordinates because there are different types of coordinates. There are polar coordinates as well, which you will fun exploring in A level. But for now, we just focus on the Cartesian. Cartesian means the XY plane, the standard stuff that you have been doing so far. Okay, so let's get to it. Sorry, computer is being funny. No. Sorry, the deadline is not the 10th, the 12th. That was a mistake. It's still the 17th. For year 11, it's still the 17th. Please ignore that message. It's written on the paper, the deadline, so please adhere to that. Apologies, my computer is being very slow at the moment for some reason. It's a brand new computer. Well, that's what happens when you don't restart your computer for a week. So yeah. Can you see my screen? Please let me know. Okay, excellent. Good. Okay, so coordinate geometry, and I'm going to start easy. Okay, I'm going to start easy, and we're going to increase complexity towards the end. So hopefully, everyone will learn something new today. Given 2 points, A and B, find the gradient of the line AB, of course, and find the distance from A to B of line AB. Okay, type 1 if you know how to do question A, and type 0 if you don't know how to do question A. Okay, so you're quite familiar with this. Okay, type 1 if you know how to do question B, and type 0 if you don't know how to do question B. Okay. Mostly ones. Okay. All right. So I'll go through this quickly. So you have 2 points, a minus 2, 3, minus 2, 3. So you just draw the point, a minus 2, 3, and b 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 7, b 4, 7, and you draw a line. So the gradient is how many squares? So you count the squares 1, 2, 3, 4, 5, 6. So that's 6, and this is 1, 2, 3, 4, 4. So a, the gradient, is change in y over change in x, and that is 4/6, which is 2/3. So the gradient is 2/3. We usually use the letter m for gradient. So the gradient of AB is 2/3. B, the distance between the points, you use the formula, the distance from A to B. This comes from the Pythagoras theorem. And that's x2 minus x1, that's the formula, squared, plus y2 minus y1 squared, which gives you square root of x2 minus x1. So that's going to be, so this is x2, y2. This is x1, y1. And it's going to be 4 minus 2 squared plus 7 minus 3 squared, which is 6 squared plus 4 squared. And this is like, well, this is Pythagoras theorem, isn't it? Because this is 6 and this is 4. So we were looking for 6 squared plus 4 squared. That's what we did here. So 36 plus 16. 36 plus 16 is 52, which is 2 root 13, I believe. Yeah, should be. Okay, let me know if I'm mistaken. So this is straightforward, and I hope that makes sense. So given the distributions of ones and zeros, I think this this makes sense. And does that make sense now? The person who had a zero. Okay, excellent. Okay. Given the same 2 points, find the equation of the line AB in 3 different ways. Okay, so 3 different ways. What am I talking about? First is the simultaneous equation approach. Simultaneous equations. 2 is the point slope formula. Point slope formula. And the third one, I don't know if it has a name. I might not remember the name. It's also a point slope formula, but let's call it 2-point formula. 2-point formula. So I'm going to arrive to the same solution in 3 different ways. Okay. So simultaneous equations. We know that any line, apart from vertical lines, is y equals mx plus c. That means we can substitute the points into the equation. We know that the line passes, so what are we talking about? We're talking about line point A and point B. We need to find the equation of that line. We know that the line passes through point A. So the coordinates of point A satisfy this equation. That means 3 is equal to m multiplied by -2 plus c. That's the first equation. And we know that point B satisfies the equation, so we substitute this into here. And previously we did the same with A. We substitute A into the equation. We substitute B into the equation, so we get 7 equals m multiplied by 4 plus c. So we have two equations, two unknowns, and all right. So what can we do? Well, we can subtract. We can subtract the two equations. We can subtract this minus that. So 3 minus 7 is -4 equals minus 2m minus 4m minus 6m plus 0. So m is equal to 2/3. Surprise, surprise, m is 2/3. Who knew? Well, yeah, we knew that because we already found it, because it's the same 2 points. Multiplication sign is a dot. Well, yes, the multiplication sign is a dot when you get to higher level maths. So please get used to that. I mean, sometimes division is written like this. This is division. So 18 divided by 6 is 3. You can also write 18 over 6. You can write 18 divided by 6. Yeah, just to keep you on your toes, you know, we've introduced so many different ways of writing the same thing. The main reason why at some point you stop using multiplication as a cross is because it's easily confused with x. And a dot is a dot. I mean, well, yes, you can confuse the dot with a decimal point. But you use x more often than you use x more often than the decimal point, I guess, at some point. I don't know. It's yeah. Whichever way you like. I do not insist that you use a dot. I do not insist that you use a cross. Okay, m is 2/3. So we found m, and now we can find c. We just substitute this into any of the equations. So let's say c is equal to 3 plus 2m. This comes from here. 3 plus 2m, which is 3 plus 2 multiplied by 2/3, which is 3 plus 4/3, which is 9 plus 4, 13/3. Okay, so answer y is equal to 2/3 x plus 13/3. This is the equation of the line. You could also write it in a different way. You can use it in a standard form. Standard. I think it's called standard form. So it's you multiply everything by 3, so it's 3y equals 2x plus 13, and then you take everything to one side, so it's minus 2x plus 3y equals 13. That's another way of writing the same thing. You need to be familiar with them, with those, or this. Okay. The second method, we're going to use the point slope formula. Point slope formula. The point slope formula says that if you have a point if you have a point x1, y1, and you have a line passing through, and if you have a line passing through, and the gradient of that line is m, then equation of the line is y minus y1 equal m x minus x1. So if you know a single point, if you know the gradient, you can write the equation like this. Okay, so we know a single point. A single point is 4, 7. You choose the any line 4, 7. And you know that the gradient is 2/3. We've already established that of 2/3. So we use the formula y minus y1, which is 7, is equal to the gradient, which is 2/3, multiplied by x minus 4. You expand the brackets, so y minus 7 equals 2/3 x minus 8/3. So y is equal to 2/3 x minus 8/3 plus 7 minus 8/3 plus 7, which should give you 2/3 x minus 21. 21 minus 8 is 13. 13/3. So y is 2/3 x minus 13/3. So we got the same result. Okay, does this one make sense? Is anyone confused? 1 for yes, 1 for I understand, 0 for I am confused. Who made these equations? Well, we can prove them, and we've proved them in. Okay, fair enough. Because yes, my plus 7 suddenly became minus. So it's plus. Yeah. Sorry. Thank you. Okay. These equations, we've proved these equations, and they are in the assignment. We have shown how you got them. The 2-point formula says that if you have 2 points, x1, y1, and x2, y2, then the 2-point formula works like this: y minus y1 over x minus x1 equals y2 minus y1 divided by x2 minus x1. Are you familiar with this formula? 1 for yes, 0 for no. Okay. And it is straightforward. You have 2 points, which I already forgot. Minus 2, 3, and 4, 7. Minus 2, 3, and 4, 7. So you draw a line, and you just straightforwardly apply this formula. Okay, y minus y1. So y minus y1 is 3 over x minus x1, x minus minus 2, so minus minus 2, equals y2 minus y1, so 7 minus 3, over x minus x1, x2 minus x1, so 4 minus minus 2, 4 minus minus 2. So y minus 3 over x plus 2 equals 4 over 6. Okay, so you can multiply, you can cross multiply. I will do this, y minus 3 equals 4/6 is 2/3, 2/3 open bracket x plus 2. So y equals 2/3 x plus 4/3 plus 3, which is 2/3 x, 4/3 plus 3, so 4 plus 9/3, which is 13 plus 13/3, which makes perfect sense. Y equals 2/3 x plus 13/3. So these are the 3 main ways how you determine an equation of a line. If you know the slope, you would probably use the point slope formula. If you don't have the slope, you would use either the first or the last one. The first one is very straightforward in terms of it's very direct, but I feel that it is slightly harder than this one. But one is useful when, for example, you don't know the points. When you don't know, you need to find the coordinates of one of the points, for example. I believe that would be useful. Okay. But you need to be familiar with all 3. I mean, you need to understand all 3. Is everyone clear on how to use the third method, the 2-point formula? Do you understand? Also, on a scale of 0 to 10, please, now. 10, I understand completely. 0, I don't. Would you like me to do another example? Yes or no? Please let me know. Another example on this, on the 2-point formula. Okay, so if you take any 2 points, so for example, 4, 6, and 7 minus 9, 4, 6, and we want the line passing through the 2 points. So we use this formula. So y is y. Y is the component y minus y1. So this is x1, y1. This is x2, y2. Y minus 6. Zero 0.33.5. Oh, 0.335. Okay, y minus 6. I might be able to do your example. Y minus 6 over x minus 4. So y minus y1, x minus x1 equals y2 minus y1. So minus 9 minus 6 over x2 minus x1. So 7 minus 4. So then I simplify y minus 6 over x minus 4 equals minus 9 minus 6 is minus 15. 7 minus 4 is 3, so that is minus 5. So y minus 6 equals minus 5 multiplied by x minus 4. And you just open the brackets. Y equals 6. Well, okay, let's not. So minus 5x plus 20. Y equals minus 5x plus 26. That's the solution. Does that make more sense? Okay. Okay. All right. Perfect. I am glad to hear. So this is another example of another example. I'll just label it so that for future generations, another example. 4, 3. Okay, getting more interesting. Given the same 2 points, find the equation of a perpendicular line going through a point C. So in this case, we have 2 points. You know what? Let's actually draw them. Let's actually draw them. So -2, 3. 1, 2, -2, 1, 2, 3. That's A. -2, 3. B is 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So this is B, 4, 7. And we have a line passing through, which makes sense. And 13 thirds, that's the y-intercept. So this is 13/3, 13 thirds. We could work this out as well, but that's not necessary at this time. So this is y, this is x. Okay, so now find the equation of a perpendicular line passing through -1, 6. So -1, -1, 6, 1, 2, 3, 4, 5, 6. Okay, let's choose another point. -4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And -1, -4, 15. Otherwise, it's just clunky. All right, so we have another point, C. C, -4, 15. And I want a perpendicular line, a line that is perpendicular to the original one, going through C. So as you can see, there's only one possibility, because if this is a perpendicular line, then any other line is not going to be perpendicular. Any other line passing through C is not going to be perpendicular. So there's only one possibility. Okay. So what do we know? Well, we know that the gradient of AB is equal to 2 thirds. What's the gradient of the line C? Well, it's going to be CD. What's the gradient of the line CD? You can tell me? -3/2. Well done. -3/2. Because if two lines are perpendicular, the product of their gradients is -1. So if two lines are perpendicular, then if L1 is perpendicular to line 2, then M1 multiplied by M2 is -1. And this is the case because 2 thirds times -3/2 is -1. Right. So 2 thirds multiplied by -3/2 is -1. So they are perpendicular. So if the lines are perpendicular, the gradients multiply to give -1. Okay. So we know the gradient of the line CD. gradient of the line CD is minus 3/2. And it goes through the point C. So we can use the point slope formula, right? Because we know the gradient. The gradient is minus 3/2. So using the point slope, using point slope formula. So y minus y1 is equal to mx minus x1. So it's going to be y minus y1, which is minus 4, minus 4, equals m, which is minus 3/2, x minus x1. Oh, sorry. Yes, I don't see what you've written in the chat, but I believe I can see with peripheral vision there's something there's something in the chat. Of course, I've made a mistake here, so it's minus 15, and then x minus 4, like this. Okay. So slope m is minus 3/2, and x1, y1 is minus 4/15, the point. And then I can do y minus 15 is equal to minus 3/2x plus minus, because it's going to be plus 4. So minus 3/2 times 4. Somebody asked me previously why we use dot for multiplication, because of this. Yeah, if I wrote a dot here, you would understand what it means. Okay. So this is the primary reason why most mathematicians don't use cross as multiplication. Okay, so y minus 15 is equal to minus 3/2x minus 6. And then y equals minus 3/2x plus 9. And that's the equation. That's the equation of the line. Right. So this line, of course, you can always substitute. Yeah, substitution always works. I think it's just this method is probably quicker. Maybe not. So this is y equals 2/3 plus 2/3 x plus 13/3. And this is y is equal to minus 3/2x plus 9. Okay. Now, so we found the equation. Very good. Now, find the coordinates of point D, the next question. Find the coordinates of point D. So this is point D, so we need to find the coordinates. Well, we know it's an intersection. So E, find the coordinates. Coordinates of point D. Well, D is on both lines. D is on both lines. So the coordinates of D, so if D has coordinates x, y, then y is equal to 2/3 x plus 13/3. thirds, and y equals minus 3 over 2x plus 9. So x and y, this x and y satisfies both equations. Both equations. So dx satisfies both equations. All right. Okay, so we just write them out and solve simultaneous equations. Okay, so the first one I'm going to multiply by 3 times by 3. This is going to times by 2. So 3y equals 2x plus 13. This one is going to be 2y equals minus 3x plus 18. What can I do? Times by 3, and this times by 2. So 9y equals 6x plus 39. And this is going to be 4y equals minus 6x plus 36. Now I add them together, and I get 13y equals 60, 75. Y is 75 13ths. Yeah, not very pleasant, but yeah, what are you going to do? I've chosen numbers randomly. That's what you get when you choose them randomly. And x, how can I find x? Just any equation will do. 75 13ths minus 30. Really? Okay, so 75 13ths minus 13 thirds multiplied by 3 divided by 2, 28 13ths. 28 13ths. Okay, so I hope you know how to do this, so I'm not gonna spend time solving simultaneous equations. So you found x and y, so these are the coordinates of point D. So we can go back 28 13ths. 28 13ths and 75 13ths. That's the coordinates of point D. And finally, they can ask us to find the length CD, which is quite straightforward. Finding the length of CD is length of CD. So I'm going to draw a line. Length of CD. Length of CD. So C has coordinates minus 415, I believe. Minus 415. Minus 415. And D has coordinates 28 13ths, comma 75 13ths. Okay. Type 1 if you think you can do this by yourself, and type 0 if you think you won't be able to do this by yourself. All right. A few responses. Okay, so you can find the length of CD. And yeah, so let's very quickly do this. CD, the length of CD. This is the modulus of CD. Sometimes just showing that it's a vector. And it's going to be CD, so it's going to be this minus that. So 28/13 minus plus 4, minus 4 squared plus 75/13 minus 15 squared. And you get something. I haven't done this, so this is the first time I'm going to do this. 28/13 plus 4 plus open bracket 75/13 minus 75. Oh, 15 squared. So the distance is 40 divided by root 13, which is approximately 11.1. 11.1. Okay. And one thing that I haven't mentioned, sometimes we will ask you to find the area of triangle ABC. So let's call it problem problem 5. Find the area of triangle ABC. Okay, ABC. Okay, so we have, let's draw it in purple. We have A, B, C. Okay, so there's so many things we can do here. So method one. So the area is 1/2 base times height. Okay, so the base is AB. So A, the area, is 1/2 area is 1/2 times base, which is AB, multiplied by height, which is CD, which we already know CD. So AB, we need to find AB. So AB is square root of -2 minus 4 minus 2 minus 4. Oh, we already know the distance, of course. We've already done it. We found AB in the previous question, and it was 2 root 13, I believe. 2 root 13, yes. AB is 2 root 13. 2 root 13. And CD is the height, because it's a right angle. So CD is the height of the triangle. And this is equal to 40 divided by root 13. And AB is, so CD is 40 root 13. Okay, so it's going to be 1/2 multiplied by AB, which is 2 root 13, multiplied by CD, which is 40 over root 13. Okay, which is 2 cancels, which is 40 square units. Ooh, interesting. Another reason why I always try to stick with exact values, surds, because you see what happened. I got a perfectly valid answer there without any, yeah. And actually, I've chosen the points randomly, so yeah. Now, method 2 is a longer method, but I just want to show you so that it's another arrow in your quiver. If you have a triangle with sides A, B, and C, we can define the half perimeter. P is A plus B plus C divided by 2. The half perimeter. Half perimeter is the sum of this angle, sum of the sides divided by 2, and the area is equal to the square root of half perimeter multiplied by half perimeter minus A multiplied by half perimeter minus B multiplied by half perimeter minus C. Are you familiar with this formula, 1 or 0? Yes or no? Ah, lovely. I love it when it happens. Yeah, so this works for any triangle. So if you have the 3 sides of the triangle, you can work out the area. I think it's Heron's formula, but I'm not, don't quote me on this. Look it up, whose formula it is. So we have a triangle. So let's work out. So we know that one of the sides is 2 root 13. So we have 2 root 13. Oh, this is going to be, you know what? I'm a bit lazy doing this because the sides are very awkward. Basically, what you will need is you'll need to find the length of the 3 sides, add them up together, divide by 2. So I'm gonna go with a simpler triangle. Let's say we have a triangle. We have a triangle 2, 3, and no, can't be 5. 2, 3, 4. Okay, 2, 3, 4 triangle. Can we? Yeah, should be fine. 2, 3, 4. So the half perimeter is 2 plus 3 plus 4 divided by 2, which is 5 plus 9 over 2, so 4.5. And so the area is the square root of half perimeter, 4.5, multiplied by 4.5 minus 2, 4.5 minus 2, 4.5 minus 3, and 4.5 minus 4. It's a very neat formula to use when you know 3 sides of the triangle. And this is going to be square root of 4.5 multiplied by 2.5 multiplied by 1.5 and multiplied by 0.5. A quarter multiplied by, why am I saying a quarter? Oh yes, a quarter multiplied by 9 times 5 times 3, which is 45 3/4, 3 root 15 over 4. I don't think we can simplify any further. which is approximately 3 root 15 divided by 4, which is about 2.9. 2.9. Oh. Okay. Okay. Now let's confirm. Let's draw this whole thing, or using GeoGebra. You're welcome to use GeoGebra to check your answers, but not to solve it. Okay, you can use it to help you, but you can't base your solution on GeoGebra. So what were the points? Minus 2, 3. Minus 2, 3. 4, 7. And minus 4, 15. Okay. Let's check the area. So area 40. Nice. Okay. This is something. Now, perpendicular line. Select a perpendicular line and point. Line and point. Okay. And let's find the point of intersection. D. And D. Okay. Settings. 2.2, 5.8. That looks about right. 2.2. That's 28 over 13 is indeed 2.2, and 75 over 13 is indeed 5.8. That is true. And what else? Well, the equations. Let's see if we can get equations of the line. Equations of a line. Ah, here it is. Equation of the line. It's rounded. I don't like when it's rounded, but this is the equation of the line. And settings. The equation of the line. Well, this one is correct. So this is 2/3. 2/3 is roughly 0.7, and 13/3 is roughly 4.3. So it works. It fits. It fits. And I'll just write this. Just draw this out. So do practice using GeoGebra. It's a very powerful tool. It's free of charge, and it's yeah, it's just cool. Okay, so this is, the line was correct. Y equals 2/3 x plus 13/3. This is y equals minus 3 over 2x plus 9. This point is 28/13, 75/13. Okay, and the area is 40. Yay. Exciting when everything is right. Okay, we've done this one. Okay, conveniently, then I don't have to change the numbering. Now, the next thing we need to talk about is equation of a circle. Oh, is that the last question? equation of a circle. And the equation of a circle looks like this: x minus x0 squared plus y minus y0 squared equals r squared. That's the equation of a circle. But it doesn't look like the equation of a circle. But remember, we were talking about in the first assignment, you completed the square, and here you need to complete the square. Complete the squares. There's going to be x squared minus 4x. Well, you need a 4 here. To complete the square, you need a 4. Now for the y, so it's plus y squared minus 6y. And to complete the square, you need a 9. Now 4 and 9 make 13, but you need 8. So it's going to be minus 5. Ew, I don't like that, but okay, that's fine. All right, that makes 0. 4 and 9 is 13. 13 minus 5 is 8. Okay, so now I complete the square. So x minus 2 squared plus y minus 3 squared equals 5. So I have a circle, center 2, 3, radius square root of 5. Honestly, I didn't expect the radius to be square root of 5, but okay. 2, 3. 1, 2, 1, 2, 3. And the radius is square root of 5, which is slightly more than 2. It's about 2.3. So it's roughly that. So this is the equation of a circle. 2, 3, radius 5. Okay. Now we need a tangent drawn from 2, 5.5 to 5.5 to 1, 2, 1, 2, 3, 4, 5. 5.5 is here. 2, 5.5. And we have a tangent line drawn to the circle. Well, it's like we have 2 tangent lines. And like this, and like this. Okay. So how do we approach problems like this? So there's so many things to consider. You have the circle, you have the straight line. You know that the line passes through this point. Okay, so I will label this one 2, 3. And I will label this point. And even though I don't know this point, I can still label it. I'm going to label it with XY. All right. Okay, so let's give them the points names. Let's call this point C as the center. This point I'm going to call A. And this is I'm going to call P. So gradient of CP. Gradient of CP is equal to change in y over change in x. So it's y minus 3 divided by x minus 2. I think that's going to come in handy. Okay, so that's the first thing I've noted. Note to self. But AP has to have the opposite gradient. Gradient of AP. Gradient of AP has to be minus 1 over the gradient of CP. Right? Because they're perpendicular. Because these two red lines are perpendicular. So forget about this line for now. There is one, but I'm not interested in that. I know that these two lines are perpendicular, so I know that they're. Oh no, sorry. Let's not make it more complicated. Gradient of AP. Gradient of AP is y minus 2 divided by x minus, so y minus 5.5, sorry, y minus 5.5 divided by x minus 2. Okay, so how well do you understand what I have done so far? On a scale of 0 to 10, please. Y minus 5.5 and x minus 2. 0. Okay, so all I've done is I've used the formula for the gradient, because I know that the gradient of a line, so the gradient is equal to y2 minus y1 divided by x2 minus x1. That's all I did. I said that the coordinates of P is xy, and I found the gradient of CP by doing y minus 3 and x minus 2. And then I found the gradient of AP by doing 5.5 y minus 5.5 and x minus 2. That's all I did. And because they are perpendicular, I know that the gradients multiply to minus 1. So y minus 3 divided by x minus 2 multiplied by y minus 5.5 divided by x minus 2, they have to be equal to minus 1. That's not going to help me too much, is it? It's not going to give me a quadratic. Okay, that's one thing. That's an equation. I'm looking at this equation and I'm seeing that it is going to help me. But if I start simplifying that, that's going to be a complicated equation. It's going to contain y squared. It's going to contain x squared. So it's not enough. Not enough for me. So I'm going to pause that. I'm going to keep that aside. And I'm going to remember another fact, that CP has to be square root of 5. The length of CP is square root of 5. And that gives me that y minus 3 Well, that literally gives me the equation of the circle, but okay, I'm gonna y minus 3 squared plus x minus 2 squared has to equal to 5. Yeah, so square root of 5 squared. And I can rewrite this as x minus 2 squared is equal to 5 minus y minus 3 squared. Okay, this is a tough one. And I'm using all right, now I have two equations and now I can solve them. But I'm gonna try to be clever. I'm gonna say y minus 3 multiplied by y minus 5.5 divided by x minus 2 squared equals minus 1. But x minus 2 squared, we already know. It's here. Yeah? So that's going to be y minus 3. Let's multiply this. Let's multiply this by that. So it's going to be like this. Like this. Okay, so y minus 3 multiplied by y minus 5.5 has to equal to minus that. So it's y minus 3 squared minus 5. And now I just open the brackets and solve a quadratic within y. So y squared minus 5.5 minus 3 minus 8.5 y plus 16.5 equals y squared minus 6y plus 9 minus 5. And wow, y squared cancels. And we've got 2.5y is equal to 4, 12.5. Y is 5. That's plus 5. Where? No, it's not plus 5 because it is minus x minus 2 squared. So it's minus that. So I've changed the signs. I changed the sign so it becomes minus 5. So y equals 5. Interesting. And then we have, if y equals 5, then x can be obtained from here. X minus 2 squared equals 5 minus 3 squared, which is 5 minus 3 squared is 5 minus 4, which is 1. So x minus 2 equals plus or minus 1. X equals 2 plus or minus 1. So x is equal to 3 or x is equal to 1. Okay, so y is 5, full stop. Okay, so this point P is either 3, 5 or 1, 5. This is 5. So this point is either 3, 5 or 1, 5. And once we have the equation, once we have the points, so this is 3, 5, and this is 2, 5. So we found the points, and now we need to draw the lines. And how to do a line through 2 points, you already know. Okay, so line, let's give it a name. It's line Q, line AP. So I'm just going to use the 2-point formula. 2-point formula is going to be y minus 5 divided by x minus 3 equals 5.5 minus 5, 2 minus 3, which gives me 0.5 divided by minus 1, which is minus 1/2. So y minus 5 is equal to minus 1/2 x minus 3. Y is equal to plus 5 minus 1/2 x plus 3/2, 10/2. So y is equal to minus 1/2 x plus 13/2. That's the first equation. And the second one, line AQ. So y minus 5, x minus 1 equals 5.5 minus 5 over 2 minus 1. Yes. And 5 minus 5 is 0.5. 0.5 divided by 1, which is 1/2. And y minus 5 is equal to 1/2 x minus 1/2. So y is equal to 1/2 x plus 4.5, so it's 9/2. So these are the two lines. And let's check that. All right, so from the top. So I'm gonna do this. So this is Desmos and going to be x squared plus y squared and minus 4x minus 6y plus 8 equals 0. That's a circle, and it looks like the circle that I have drawn. So it looks like I was correct. Then we draw a line. So y equals minus 1/2 x plus 13/2. And it is a tangent, and it does go through this point to 5.5. So that makes sense. And y is equal to 1/2 x plus 9/2. Which just is very satisfying. This is 1/5. Why does it not? Okay, doesn't like dots. Okay, 3/5, 1/5, 2, 5.5, and I think, yeah, it just works. Oh, come on. Please. Okay. I can take a screen. Okay. Okay, so indeed, I got there. Okay. U15, and what did I say? Oh, I said 2/5. Yeah, it's 1/5. Sorry. 1/5. Thank you. All right, so that's it. That's it for today. I hope this was useful. Okay. Type I don't know. Type 1 if you learned something new today. Okay. Assignment 3. Assignment 3. I've published it. I'll send you a link right now. Computer is being very slow. That's the end of the session. I'm going to post the link in the chat just once more. Otherwise, you're free to go. Enjoy your evening. The assignment can be found on Canvas. So please, if you log into Canvas, you'll be able to find it, to see it. Okay, so here it is in the chat. So enjoy.